This lecture, this lecture is on volume and surface area. The volume is the amount of space on the inside of a solid. A solid is a three-dimensional figure. Unlike the flat surfaces that we were finding the area of, the solids, we're looking at the amount of space on the inside of a three-dimensional figure. Surface area, we're trying to find the area, total area of the different faces of the solid. Polyhedron. A polyhedron is a three-dimensional figure bounded on all sides by polygons. So this is an example of a polyhedron. Each side is a polygon, and the polyhedron is a three-dimensional figure. When we're looking for the volume of a solid, we're trying to figure out how many unit cubes would fit inside that solid. So here we have what we call a rectangular solid. This is a three-dimensional figure that's shaped like a box. So you can think of this as a box, and you're trying to find out how much space is on the inside of the box. Now, to find the space on the inside of the box, you can find the space on the inside in terms of the number of cubic inches, the number of cubic feet, the number of cubic yards. So you're trying to figure out how many unit cubes would fit in there. Now, if you're trying to do it in terms of cubic inches, then a unit cube would have an inch on each side. So this would be a unit cube here in figure 10-22. One of these little cubes would be what we call a unit cube. And a unit cube can be an inch on each side, it can be a foot on each side, a mile on each side, a kilometer on each side, and so forth. But the main thing is unit. Unit means one. So a unit cube is 1 inch on all sides. So you're trying to figure out how many of those unit cubes would fit into the rectangular solid. And we could, if we had a lot of little unit cubes, we could just see how many would fit in there. But the way we find the volume of different solids is by using a formula. And this is the formula for the rectangular solid. For a rectangular solid or a box, the volume is equal to length times width times height. And this is the length in this case, this is the width, and this is the height. So of course, you can put LWH in different places and get the same answer. So if someone decides to call this the length and this the width, you will still get the same answer for L times W times H. If you have a cube, any cube, this is not just a unit cube. If you want to find the volume of any cube, you use the formula V equals S cubed. Each side is the same. The length for a cube, the length is the same, the width is the same, and the height is the same. So if you use LWH, you would have S times S times S. because each one of these measurements is the same. And of course, S times S times S is the same as S cubed. So these are the formulas that you will use to find the volume of a rectangular solid or the volume of a cube. Here's an example. You have a rectangular solid here. The length is 4. The width is 30. The height is 11. So you just multiply 30 well, you multiply 4. Oh, wait a minute. This measurement here is in inches. All the units have to be, all the sides have to be in the same units in order for you to find the volume. So in this case, you have to change the inches into feet before you can find the volume in cubic feet. The question asks you to find the volume of the rectangular solid pictured in figure 10-23. So in order to change 30 inches into feet, we just use a proportion in order to do that. We know that as far as inches are concerned, 1 foot is equal to 12 inches. So you can say 1 over 12 equals x over 30. And then you can cross multiply. And when you cross multiply, you get 30 times 1 over 12 equals, and then you do the work there, you get 30 over 12, which equals 12.5. So this 30 inches here is really 12.5 feet. Once again, all your units have to be the same type of units. So that's why we had to change the inches into feet. And once we do that, change that, then we just multiply L times W times H, which is 4 times 2.5 times 11, which will give us 110 cubic feet. And you have to make sure that you get your units correct here. You can call it feet cubed or unit feet or cubic feet. Okay, so that's the volume of the rectangular solid. Okay, here's an example. You want to find the volume of a swimming pool. The pool is a rectangular solid, 18 feet wide, 36 feet long, and has an average depth of 4 feet. How many gallons does it hold? There are 7.48 gallons and 1 cubic feet. So here first you have to find the number of cubic feet, and then you have to convert the cubic feet into gallons. So we have to use the measurement for that, which we can find online, or we can find by looking back in the previous sections of our textbook. So for the solution, it's best to draw a picture. Even though a picture is not drawn here, draw a picture of a rectangular solid. And then after you draw a picture of the rectangular solid, put the measurements on there. And then just plug everything into the formula. And that will give you a volume. You will have everything's already in feet as far as your measurements are concerned. So you would have L times W times H, which would be 36 times 18 times 4, which equals 2,592 cubic feet. And then, of course, we convert the cubic feet into gallons. And there are, well, they tell us in the problem that there are, we don't even have to look it up online or look it up in the previous sections, because they tell us that there are 7.48 gallons in 1 cubic foot. So when you set up that proportion, you would have 1 over 1 over 7.48, which gives you the cubic feet over the cubic gallons, equals 2,592 cubic feet over X. So if you put your cubic feet on top on one side, you have to put it on top on the other side. So as you can see there, you cross multiply, you get 2,592,000 times 7.8 over 1 equals 19,338 gallons. So that means that would be the capacity of the pool in gallons. Okay, next we have the cylinder. You have to be able to use the formula to find the volume of a cylinder. And a cylinder is shaped like a can. This is the radius of the cylinder, and this is the height of the cylinder. And those are the only measurements you need to know to find the volume of a cylinder. The volume of the right circular cylinder is given by this formula: V equals pi r squared h. V equals pi, which is estimated at 3.14, times the radius squared times the height. Okay, next we have an example of how you find the volume of a cylinder. How many cubic inches does a soup can hold if it is a right circular cylinder, which is what this type of cylinder is? Technically, it's a right circular cylinder, with height 4 inches, radius 1.5 inches. That's all you need to know, class. The height and the radius. Pi, if you have the pi key on your calculator, use that, because if you do, your answers will come out more accurate and more in line with the answer in the back of the book. So the question is, how many ounces are in that cylinder? So you have to have the conversion factor for cubic inches to ounces, because the measurements are given in inches. You find the ounce in cubic inches first. Then after you get the ounce in cubic inches, you convert the cubic inches into ounces. And 1 ounce is about 1.8 cubic inches. All right, so the radius is 1.5 inches. The height is 4 inches. We substitute those numbers into the formula. We get pi times 1.5 squared times 4. And we multiply everything together. We get 9 pi, and then using the pi button on our formula, multiply 9 times the value of pi in our calculator, and we get approximately 28.3 cubic inches. But we haven't finished because they say give the answer in ounces. So we set up the proportion. 1 ounce is equal to 1.8 cubic inches, and we would have X ounces on top equals X ounces on top over 28.3, and then we would cross multiply, and we get 28.3 times 1 over 1.8, which equals 15.7 ounces, which is the final answer to our problem. Okay, next we have the pyramid, and this pyramid has a rectangular base, and that's the base here, as you can see the bottom of the pyramid. As indicated here, a pyramid is a polyhedron whose base is a polygon and whose sides are triangles. So that's the definition that we're using for a pyramid, and this is the only type of pyramid that we will discuss in this class. You have other types of pyramids, but this is the only type that we will discuss. Now, the formula for the volume of a pyramid, if you want to figure out how much space is on the inside of a pyramid, then you use this formula here. V equals 1/3 big B times H. And here, big B does not stand for the base. Big B stands for the area of the base. So if you look at figure 10.14, you have a rectangle, and the area of the base would be the formula for the area of a rectangle. And the area of the base would be L times W. So that's what you have to do to get big B. Big B equals L times W. And then once you get big B, you plug it in here, and you multiply by 1/3, and then times about the height. And the height is the perpendicular height. If you go, it's not the slant height. If you go from the vertex, if you're looking at figure 10.4, you go from the vertex straight down, to the center of the pyramid at a right angle. You have a right angle there. That imaginary line that you're drawing from the center, apex of the pyramid to the center of the floor of the base of the pyramid, and it'd be a 90-degree angle that height would make with the base. So that's how you determine the height. So keep that in mind. Once again, the base, L times W, then times the width, and the height has to be what we call a perpendicular height. So then you multiply everything by 1/3. Okay, as you can see, the height represented, as I said, is the perpendicular height. Drop that line straight down to be perpendicular to the base. And this type of geometric figure. So there you have the area of a pyramid. Here's an example. Since the base is a square, all right, if you have a pyramid and the base is a square, then you can still say L times W, or you can just say S squared for the area of the base. Okay, this example 4, find the volume of a pyramid. The Great Pyramid in Giza was built by the Egyptians roughly 4,590 years ago. It has a square base measuring 230.6 meters on a side. So to get the area of the base, you just have to square 230.6, and is 138.8 meters high. Find its volume. So since they said it's 138.8 meters high, we assume that that's the perpendicular height. If you go from the apex of the pyramid directly down to the base at a right angle, that represents the height. So we assume that indeed is what we have here. In the solution, if you look at the solution there, since the base is a square that is 230.6 meters on a side, its area is 230.6 squared. Or you square 236, and you can check it out on your calculator, see if you get it right. 53,176.36 square meters. That's what you get for the area of the base, and that's what big B represents in the formula. You see, big B here is the area of the base, so we're going to have 1/3 times that number, and then times the height, and that's what we have in the formula here. We have 1/3 times what we got. And when we multiply there, 1/3 times 53,176.36 times 138.8, which is the height, we get approximately 2,460. No, we get 2,460,293 meters cubed. So that gives us in meters cubed, but we asked for it. Okay, it didn't say any other measurement. So meters cubed will be fine. That will be the answer. If they don't tell you what units to put it in, then you can just use the units that you already have. But be sure that you have cubic units. So those are cubic meters that we have. And that's the end of that problem. Okay, the next figure, next solid that we have to find the volume of is the cone. And this is what we call a right circular cone, because if you go from the apex down to the center of the base, you have a right angle. That line would form with the base, and that measurement here on this cone, you see how the cone looks. It looks like a ice cream cone turned upside down. So the base makes the height makes a right angle with the base, as you can see there. And then you have the radius. So the formula for the volume of a right circular cone is V equals 1/3 pi r squared h. Now when you look at this formula, you have to use the order of operations to get the answer, which means you have to do your exponents first. First you have to square r. Then after you square r, you do your multiplication. And generally you do it from left to right. Okay, here's an example. We have a right circular cone. The cups attach to a water cooler, and those cups on a golf course are right circular cones with the radius 1.5. Okay, so in this case, we just substitute everything into the formula. We have 1/3 pi. You can use the pi button on the calculator. R squared, so we have 1.5 squared, and then times 3, which is the height. And we multiply, we get 7.1 inches cubed, or cube inches, or cubic inches. And then, of course, in this problem, they asked us to find the number of ounces. So we have to use the conversion factor that they gave us in order to find the number of ounces. They said that 1 ounce is about 1.8 cubic inches. So when you set it up as a proportion, you would have 1 ounce over 1.8, 1 over 1.8 ounces over cubic inches equals x over 7.1. And then you would cross multiply and you get what we have here. You have 7.1 times 1 over 1.8, which equals 3.9. That means that the cup holds about 3.9 ounces of water. Okay, the next geometric figure is what we call a sphere. It's really called a sphere. Some people call it a spear, but the correct pronunciation is sphere. Sphere. So this is an example of a sphere. A sphere is shaped like a ball, shaped like a basketball, or shaped like an orange. That's what a sphere is shaped like. And the only thing you have to know about the sphere in order to find the volume is the radius. The formula for the volume of a sphere, as you can see there, is V equals 4/3 pi r cubed. This formula would tell you how many unit cubes will fit inside that sphere. Here's an example. The famous ball at Epcot Center in Orlando has a diameter of 164 feet. Find its volume. So they give us the diameter. You look at the formula, the diameter is not in the formula, but the radius is in there. So this means that you have to find the radius. And as you know, the radius is 1/2 the diameter. So if the diameter is 164 feet, the radius would be 82 feet. And that's all you need to know to find the volume of a sphere. The Earth is shaped like a sphere. The Moon is shaped like a sphere. So the volume is equal to 4/3 pi, and you can use the pi button on your calculator later. That's what's recommended. Times 82 cubed. Once again, you have to use that order of operations, so you have to cube the 82 first. 82 cubed would be 82 times 82 times 82. And then after you do that, you multiply that times pi times 4/3. And that gives you 2,309, not 2,000, but 2,309,565 cubic feet. That's what you would have for your answer for the volume of that sphere. Now, for the surface area, you're trying to find the total area of the faces of a solid. That's what you're trying to do. In other words, if you take that solid and you take it apart and flatten it out, then what would the area of the different surfaces add up to? That's the question that you're asking when you're someone is asking if they ask you to find the surface area of a solid. So to find the surface areas of solids, we use formulas. And these are the formulas that you have to use to find the surface area of various solids. To find the surface area of a cube, how much area would be in the cube if you take that cube and you take it apart and flatten it out? Because when you talk about area, you're talking about a flat surface, the amount of space inside of a flat surface. So if you take that cube and flatten it out, the surface area, which is represented by SA, is equal to 6 times S squared. That's how you find the surface area of a cube. Surface area of a rectangular solid. This is not the surface area of just a rectangle, but of a rectangular solid. The formula is surface area equals 2 times the height times the width, plus 2 times the length times the width, plus 2 times the width times the height. That's the formula for the surface area of a rectangular solid. Surface area of a right circular cylinder, SA equals 2 pi r squared plus 2 pi r h. For a sphere, the surface area is equal to 4 pi r squared. For a pyramid with a square base, the surface area is equal to L squared, which is the length squared, plus 2 times the length, times the square root of the length squared over 4 plus h squared. That's the formula you use to find the surface area of a pyramid. And finally, the surface area, not finally, but makes the surface area of a right circular cone. If you have a right circular cone, the formula is SA, surface area equals pi r squared plus pi r times the square root of r squared plus h squared. And okay, so those are the surface area formulas. We don't have to find the surface area of a sphere. So here's an example of finding the surface area of a cylinder. How many square inches of sheet metal are needed to form the soup can in example 3? How many square inches of sheet metal are needed to form the soup can in example 3? So when we're looking for square inches, square corresponds to area, cube corresponds to volume. Just plain units correspond to perimeter. So we know we're looking for the area because it said how many square inches. And since we're talking about a soup can is a solid and it's shaped like a cylinder. So we need the surface area of that cylinder. If we go back and look at example 3, the radius was 1.5 inches, the height was 4 inches. So the formula for the surface area is 2 pi r squared plus 2 pi r h. So all we have to do is substitute the numbers in. We can leave pi as it is because we can use the pi button on our calculator. R is 1.5, so that's squared plus 2 pi times 1.5 times 4. And we do all the calculations there. We get 51.8 inches squared or square inches. Okay, next example, finding the amount of building material needed. An aluminum silo is being made from a right circular cylinder and with a right circular cone on top. So if you look to the left here, you have 2 geometric figures in one. On top, you have the cone. On the bottom, you have the cylinder. So to get the volume of the entire figure, you use the formula to find the volume, surface area. To get the surface area of the entire figure, you use the cylinder formula to get the surface area of the cylinder. You use the cone formula to get the circular area of the cone, and then you add those two together to get the total surface area. So as we have indicated here, the surface area for the cylinder, the formula is pi r squared plus 2 pi r h. You just plug in the numbers. We have 5.5 feet, so here we're using 5.5. Just change that fraction 1/2 into a decimal. And here we have plus 2 pi times 5.5 times 14. And we get 578.8. That should be feet squared. That's a mistake in the textbook there. Area is always measured in square units, not cubic units. When you have cubic units, that refers to volume. So once again, that's a mistake in the textbook. Be sure to note the mistake and make a correction in your notes. And then we have to find the volume of the cone. And the volume of the cone, this is the formula for this. I'm sorry, not the volume of the cone. I'm making that mistake myself. We have to find the surface area of the cone. So the surface area of the cone is equal to pi times r times the square root of r squared plus h squared. That's the formula that we have for the surface area of the cone. So we just plug in the numbers for the cone. For the cone, the radius is 5.5, so we substitute that in for r. And for the cone, the height comes from the apex and is perpendicular to the base. But it's not the slant height, but the perpendicular height. That's the height of the cone, and that's 4. So we have plus 4 squared. So we plug everything into the formula as indicated here, and then we do all the operations. You have to do what's under the radical sign first, and then you take the square root of that, and then you do your multiplication. So our answer here for the surface area of the cone is 117.5, and that should be feet squared. So then you add your feet squared together, which they made a mistake here and put it in cubic feet, even here. See, textbooks, there are mistakes in textbooks. Most textbooks have mistakes. To get a mistake-free textbook, it might take really 15 years to publish a textbook that's error-free. So, if you waited that long to publish a textbook, the textbook would be outmoded. It'll be out of date. It'll be obsolete. So that's why you have to know when there's a mistake in a textbook. There are mistakes online, on the internet, on Facebook, on Twitter. There are mistakes out there. In Wikipedia, there are mistakes out there. And you have to be able to realize when there's a mistake somewhere. If you're not able to realize that, all you're going to get is a lot of miseducation. That's all you're going to get. There are mistakes in the psychology books, mistakes in the history books, mistakes in the economics books. There are mistakes in there, and you just have to contend with mistakes. And you, as a learner, you have to realize and say, "Hey, this is a mistake." You have to realize that when a mistake is a mistake. So we don't have to be able to find the surface area of a sphere. We just go as far as the surface area of the cylinder. Okay, for homework, you want to do the odd problems at the end of the section. Beginning on page 594. Those are the problems you want to do for homework. In fact, let's do every other odd, because I assigned you problems from the previous section, and you did every other odd. So if you do every other odd in this section, I think that'll be good. But be sure to do some of all the different types. So if you see a type of problem that's even and you don't have that type in the odds, then be sure to do it so that you'll know how to do that type of problem, because really you're responsible for all the different types of problems uh, in the sections. Surface area. I'm looking at these examples here, the exercises, and it says in exercises 21 through 32, find the surface area of the figure from the given exercise. So if you look at number 31 and 32, you want the surface area of the sphere. So we need that formula for the surface area of the sphere also. And okay, I'm looking back. I was trying to see if we had the surface area of the sphere. There it is. There it is. Surface area of the sphere. Okay, so this is the formula that you use for the surface area of the sphere. Surface area is equal to 4 pi r squared. So that's the formula that you use there. It's on page 592. We didn't have to find the surface sphere, but we do. I'm glad that I took a look at the exercises and verified that. All right, so that concludes the lesson on volume and surface area. And I think that you should be able to do the exercises and figure out the answers to the various exercises that we have at the end of the section. Some of the problems are more challenging than others, but you have to be able to use your brain to try to solve those problems. And basically in this course, in order for you to really do your best and really be really successful, you have to be able to solve problems that you've never seen before. And your brain is capable of doing it. You just have to think hard, figure hard, try this, try that, and so forth. But the brain is a very powerful organ, and the brain can solve problems that it's never seen before. That's one of the things that's so outstanding about the brain. Computers are limited. They can only solve problems that have been programmed into them. But the human brain is more powerful than any computer. maybe 1,000 times or 100,000 times more powerful than any computer. So work hard on the problems and do your best. This concludes our lecture on volume and surface area.